Okay, spend about 10 minutes or so going over this. So give another name to plane P using 3 non-collinear points. So what would be another example? What would be another way to write this? Did we all find it? After page 23, it says chapter 1 practice test. It's in the chapter 2 notes packet that I gave you that we've been working on. It's really close to the end. Are we all there? Please help each other find it. This is what it looks like. Geometry chapter 1 practice test. So we're going to give another name to plane P using 3 non-collinear points. So a couple examples would be, I could call it plane FBD, because the 3 of them are not all on the same line. So this is all for like number 1. These are like examples of what you could put because there's multiple solutions. What else could I call this? Plane. Well, I could go the opposite way. Instead of going from F to B to D, right? I could do C and B and D. Another one would be CDF, right? Call it CDF. Any of these would be the right answer. You only have to put once, huh? Honestly, yeah. Okay, so those are like 3 examples. Number 2 is asking for another name for line M. So we see line M is right here. What's another way I could name it? Line AB. So how you write it is important. So you could say AB, and notice that I have arrows on both sides, or you can say BA. That's fine as well. Cool. Number 3, say name 3 collinear points. Wasn't talked much. Jacob, what do you think? What's C, B, and F? Perfect. You guys feel pretty confident in these? Okay, 8 hours later, we're solid. All right, use the figure below to answer 4 through 7. Name a point coplanar with A, B, and E. Okay, A is here, B, E. Okay, so I'm looking at this plane right here. So I want to know another point that's coplanar with it. Yeah, I could say H or J. That should work as well. Awesome. Next one says, name a segment parallel to CD. So let me erase this nonsense. CD is right here. So I need a segment that's parallel to it. Segment that's parallel to it. What did you say? EF. EF. Okay. And it's a segment. So am I putting arrows at the top of this? No, just a line, because it's a line segment. It's fine. I'm just gonna start calling people YOLO. Okay. So I listed this guy. What's another one? Maya, what's another one? Yeah, so I'll just call it AB. That should be fine. Or AB. And of course, you could say BA, FE. Here it's saying the same segment. Let's do name 3 collinear points. Chauvel, what's 3 collinear points? Exactly, A, H, and B. Or I have another set I could use. What do you think, Dylan? What's another set I could use? So 3 collinear points. So to have 3 points that are on the same line. So I'm on number 6. So she said A, H, and B. So I have these 3 points that are on the same line. They're taken care of. Exactly. B, J, and F. So of course, on your actual test on Friday, you only have to say one of them. Same way on number 5, but I'm giving you, I'm going through fully, that way you can see you have options. Number 7 is asking, how many planes are pictured here? How many planes are there? So if you could pull this 3D out, how many planes are there? Jacob. 5. Perfect. All right. What is the intersection? Let me pause. Are we good so far? If you have questions, you just gotta be like, yo. Because we're just gonna like keep reviewing. All right. What is the intersection of plane ABF? So that's ABF is this guy. And plane CD. So plane CDE. CDE is the one on the bottom here. So 2 planes intersecting give us a what, Noah? 2 planes intersecting is a... Huh? What'd you say? So when 2 lines intersect, you have a point. When 2 planes intersect, you have a...
line.
You have a line. You have a line. Okay, so this little like tidbit of knowledge, when you're writing, you know you're going to have a line. So what line is my intersection of these 2 planes? Do you know, Noah? What line is the intersection of these 2 planes? Because you have the bottom, and then you have the like diagonal one. What line is connecting them? Not quite. So it'd be EF because it's touching both. Right? This line EF is touching both of the planes. So it'd be EF, or you can say FE. That would also be fine. And keep in mind, it's a line, so you have to have the arrows on both sides. Okay, rad. Okay, so what is the distance between points J and N? Ashton?
J and N, 1, 2. Let me count it here. So it's accurate. 1, 2, 3, 4, 5.
J and N? Oh, I was doing the wrong one. 3, 4, 5, 6, 7, 8, 9, 10. Okay.
10.
Yeah, 10. 10. What is the midpoint between points K and M? Let's see. Maya, the midpoint between K and M. I just kind of gave away the answer. She just averaged them.
She said
K, I didn't hear her. What?
she said L.
Oh, that works. What is the midpoint between them? You could write, well, L would be okay, but I want to know like the number.
Oh,
So that'd be -2. Between K and M, it's halfway between. All right, refer to the graph below. Let's pause here. Do we understand this? Any questions? Hoping we're grooving. Okay. Refer to the graph below to answer questions 11 through 13. So 11 wants you to draw and label, and 12 wants you to find the midpoint. So I want you to draw and label A and B. So we have them. So -4, 6. So that's A at -4, 6. B is at 1, 2. So we want to know, what is the midpoint of A and B? Chauvel, how would I figure this out? How do I find the midpoint? Not quite. You have to average the x's and average the y's. So you take your x's, add them together, divide by 2. Take your y's, add them together, divide by 2. So this is going to equal -3/2, 4. Yeah. So if I would go and plot this, it should be exactly halfway between. So let's see. You don't have to do this, but this is like 1.5, 2, 4. So this point looks about halfway. So that's the midpoint. You don't have to draw that, but I just want to make sure you're clear with where it is. We see that it is halfway between. What is the distance between A and B? So you have to use the distance formula. Let's go to Ashton.
And the distance formula is going to be square root parentheses x2, which is 1, minus x1, which is -4, turned down to a plus, end parentheses, and then square that, plus y2, which is 2, minus y1, which is 6, end parentheses, square, and then that's it. Then you're going to do the plus and minus, and then, yeah.
Is this what I think this is what you were saying.
Yep.
So the distance formula, x2 minus, so I'm going to upload this when we're done. X2 minus x1 squared plus y2 minus y1 squared. And then you go through 1 minus -4 is 5, 2 minus 6 is -4, and then I'm going to leave it because 41 is a prime number. So I can't do anything with it.
Thank you. You have to do these prime numbers.
Let's see. Yeah, we can do number 14, that'll be done for the day. So angle LMN and angle NMO form a linear pair. Okay, so we should draw that. It forms a linear pair. Find the measures of angles if one angle has this and the other is that. Okay, so linear pair means they add to 180. So if I take 3x plus 10 degrees plus 2x plus 45, I add them together, I get 180. Because this is measure of LMN plus the measure of NMO should be 180, so I just filled in for them. Combine like terms. So I found x, but I'm not done because I have to find the actual measures. I'm not just solving for the variable. So the measure of LMN is just going to be 3 times 25 plus 10. So if you have 3/4, you have 75 cents. 75 plus 10 is going to be 85. So LMN is 85 degrees. And we know that 85 degrees plus whatever the measure of NMO is will be 180. So you subtract 85 from both sides, you find the measure of NMO is 95 degrees. Or you could just plug in your x value into that and you would get the same thing. Cool, so that's where we'll stop for the day. Pretty solid. We're about like, what, halfway through the practice test. That's rad.
Oh, no.